Okay, so the 21st problem in Leet code is merging the two sorted linked lists. Okay, basically here we will be given the two linked lists which are already sorted. Okay, what is the expected solution is we'll have to merge them, and the condition is it should still be in a sorted order. Okay, that is one thing, and as a result we don't have to return each element, we just have to return the head node here. Okay, so that is the problem about. So how are we going to merge it? Before directly going to that enhanced one, right? I'll just want to brief how I was approaching this problem. Okay, so what I used to do is I used to create a one dummy node because we need to return a head node, right? We cannot we need a start point, right? So I used to create a dummy node first. Okay, I used to build a separate linked list altogether. So I had a dummy node somewhere here, and then I used to check L1 whichever is less. If it is which is less, okay. Let's say that if this is less, I will be creating a new node with this value and appointing my that new linked list to dummy node to this. Okay, I will be upgrading my start pointer, whatever I used to call that as a start. Okay, dummy as a start. And if it is less than or equal to, right, we used to I used to point that when I'm building that new linked list, I used to create a new node and point it to it. Okay, and I update my list one pointer to the next one. Okay, and similarly in the next iteration also I will compare whichever is less. Let's say that L2 is less, right? I will be creating a node with that, and I will be pointing my whatever the linked list I am building, I will be pointing to that, and I will be moving my list to update pointer also. Like, I mean, list was pointing to here, it will be pointed to here. Similarly, I have to iterate through it, and I have to build a new linked list like this. Okay, and also at the end, let's say that if one of the list is more bigger, right? So we don't have to iterate through it again and again. Correct. Once any of the list gets empty, let's say that now it is 3 3. Okay, let's say that there are six elements in the list to do. Okay, so as we after doing some calculation, list one would be empty, right? And we don't have to check again and again, so we can just point our whatever the linked list we have, we can point it to here. Let's say that is here, it is a 5 6 7 left, right? I will point my start dot next to this whatever the linked list I built so far. I will just point it to the remaining nodes, so that I'm good, I don't have to do that calculation, right? That's what this part is about. And this part is about comparing the two values. Okay, like this solution time complexity wise, it was like 40 to 50% good compared to the overall Python code submitted, right? It was for 40 to 50% good. So but after looking for the online, right, like, I mean, the enhanced version, here is the enhanced version. Like there is a bit of similarity, but there is some changes. Okay, let's see that now. Let me clear this quickly. So basically here also, right, we will be, one second, few more. Okay, yeah. So here also we'll need a dummy node because we'll have to return a um what is it, we'll have to return a header node, right? Here also we will be needing it, the dummy node. Okay, so instead of creating a new node, we will be trying to reuse whatever the node that is already created, basically. Okay, so what is the logic here? Logic here is exactly the same. So we'll be checking here L1 is less than or L2. We need to build it in a sorted way, right? So we will be checking that L1 is less than or L2, right? So L1 is less, correct? So what I will do is whatever the dummy node or start node or current pointer I have, right? Current pointer, let's say that my current, I am building a new list. Okay, and have a dummy node basically, and my pointer is pointing to this location. Let me just pick this. Okay, this pointing to this location. So I will, let's say that L1 is less, so I will point my the first whatever the dummy node to this one. Okay, and once I read this value, I will have to move my pointer. Let me just pick a new color. I will point my pointer to a new color. So sorry, I will move my pointer to the next node. Okay, so now this is being, dummy node is pointing to this. Okay, and but L1 is starting from here, L1 is pointing to this. And now we will do the same comparison again. Let's say that we'll compare L1 is here, L2 is here, we'll do the some comparison. Whichever is less, I will point that my starting to the next one. Okay, start will be pointing to the what is the current pointer, right? Current pointer will be pointing here. L1 is here, L2 is here, my current pointer is located here. And now one is less than two, right? Whichever is less, I need to point my current to that. So I know that this is less. Next, I will pointing my this to this. And once I read this value, I will have to update my pointer. I will move. I will move L2 is equal to L2 dot next. Okay. I will move my pointer. I will set my start like whatever is that, right? Current pointer to this, and also I have updated my pointer of for the list two. Okay, so now similarly we will continue now. Whichever is less, 2 is less, we'll go here, and once we're at this, we will update our L1 pointer, and then again compare between 2, 3 and 4. So 3 is less, so we will be coming to this, sorry, coming to this, and we'll update our L2 pointer. So similar at the end, right? We have 2 now, 4 less than 4, whichever is the 4 is less, not less than 4, right? It is equal basically, but we are not we can pick either of this, but we do, as we don't have an equality check, so it will be coming here. So we will be reading this, and now, right, we are done completing our iteration through L2, but only L1 is left, right? So so what we can do just now is we can point our current to the old L1, right? We don't have to update anything, we just have to point. Let's say that it will be more clear if I add few more elements. Let's say that we have 6. Okay, we have 3 more elements here. Okay, we have iterated through L2, and there is only L1 left. There are 3 more elements. I don't have to iterate through this again, right? 4 is not, 4 is less than or something, or 4 is less than 5, nothing like that, right? I will just point my L1 is nothing but this much, correct? I will, whatever the pointer, whatever the linked list I have, right? I will just point that to L1 now. Okay, so that it will be automatically picked, right? Like, I mean, 4 will is already pointing to 5, 5 is already pointing to 6. So what I will do is, whatever the linked list I am building new, I will just point it to L1. I'm good. Similarly, let's say that if there is any other question where L2 is bigger than L1. Okay, L1 is just a 3 element, but L2 is having 6 elements, right? In that case also, what we'll have to do is, we'll just, whatever the pointer we are left with, the current pointer, we should point it to L2. Okay, now let's quickly jump on to the code, right? What is the, how is that implementation looks? So we will set our dummy pointer first. Okay, we'll set our dummy pointer, and here we will check, we'll have to iterate through both the nodes, right? L1 and L2. So we will check if both should be existing. List 1 is also there, list 2 is also there, none of them is empty. Okay, so now if my list 1 value is less than the list 2 value, list 1 value is less than list 2 value, what we'll have to do is pick the list 1, because the result should be in a sorted way, right? So we will be picking that, whatever the pointer, whatever the linked list I am building, right? The result 1, we will set the new node. Initially it is currently, it will be a dummy node. We will go to the least one. Least one is pointing to this, correct? Least one is pointing to this, we'll point to that. Once, as soon as we read this value, we need to make sure that we move our least one pointer to the next one. So that's what we are doing. Least one is equal to least one dot next. Actually, we'll have to update our current pointer. Actually, like, first, this is like a executed once, right? This is a tuple actually. There is no such order. Like, I mean, list one dot next will be executed first. Whatever that is value there, it will be there, and it won't be assigned as quickly, right? List one will be there. It will prepare a tuple, and then it will be assigned to this. So don't confuse, like, list one is equal to list one dot next now, and we are assigning cur to the list one. So we don't, like, it's not like we are pointing our current pointer to 2, right? That's not correct. So if we split it into multiple statements, right, it would to simplify this, it would look like our current pointer will point to the least one, meaning our whatever the list one is here, right? We will point our dummy node to this. Okay, and then we will move our list one pointer to the next. That's what is happening here. Okay, similarly, when it is less than this, we have read the value from the list one. Let's say that if it is equal to or greater than, right? Equal to means we can read either L1 or L2, but let's for now, let's just assume that if it is less, we'll read the L1, else we'll just read the value from the L2. Okay, so similarly, what will happen in the next case is, we, as our L1 is here and L2 is here, here, right? L2 is less than L1, so we'll be coming to here. Whatever the current pointer with that is pointing to 1, we'll point to this, just like we saw before, and then we'll make sure to update our pointers as we read the value from the list 2. Also we'll update our L2 pointer, and also we will point our cur to this. Okay, that is it actually. And also, as I mentioned previously, if let's say that once any one of this is completed, right, will completing the iteration from this while loop, and we'll be checking which is left, right? Either it can be list 1 is left or list 2 is left. Whichever is left, we'll be pointing our linked list to that list, that linked list, so that our pointer will be pointing to that. We don't have to iterate through it. Let's say that if L2 is having 5 6 7 8, we'll be just pointing our current pointer to that, so that it will automatically taken care. And also, as they're asking for a head node, right, this is a dummy node we started with, but this does not hold any actual value. This just holds a value 0, correct? By default it is 0. It holds a 0, but we don't want this, but we want whatever the values we want is start from the next one. So that's why we'll have to return a dummy node next. That will be the head of the merged linked list. That's it. Yeah, thank you.